With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The given question is, for an AC circuit shown in the figure, show that the resonance frequency is given by f equals to 1 over 2 pi under the root 1 over LC minus R square by L square. So now see, we're given a circuit in which RL components is in series with each other and they are in parallel with a capacitor. Okay, so let me just replace and redraw the circuit with their respective reactances. Okay, so we have a capacitor whose reactance will be given as minus j over omega c, right, where omega is the angular frequency of the given voltage source, okay, or AC source, and resistance will be represented by R only. And further we have inductance whose reactance is given as by j omega L, okay, and we have to find the impedance, okay, impedance of the circuit. So clearly we can see that R and j omega L are in series, so I can write Z will be equals to R plus j omega L is in parallel with minus j over omega c component. Okay, so further using the formula for the parallel combination, we have Z will be equals to R plus j omega L whole multiplied with minus j over omega c divided by we have R plus j omega L minus j over omega c. Okay, so multiplying this value in the numerator, we will get minus jr plus this would become minus j square into omega L whole divided by omega c, right? And further in the denominator, we will get here, taking the LCM, we will get omega rc plus we have j, we can take common, and we will get omega square LC minus 1, right? So Z further, now C denominator we will have omega C also. So this omega C and omega C will cancel out, and further to solve this we can rationalize, okay, and see one more thing about the property. We have j square is equals to minus 1, or I can write minus j square is equals to 1 only. So I can replace here minus j square by 1. So here I will get minus jr, so this would be plus omega L whole divided by we have omega rc plus j times omega square LC minus 1, and to rationalize we have omega rc minus j times omega square LC minus 1 whole divided by omega rc minus j omega square LC minus 1. Okay, so further on solving this we will get Z equals to, so multiplying in the numerator part we will get, so this will be minus j r, this will become r square, okay, r square into omega c. Further we have minus j and minus j, so that would become plus j square into r times omega square LC minus 1, plus we have omega L into omega RC would be omega square RLC. Further we have minus j times omega L times omega square LC minus 1. Okay, and divided by we have the denominator portion as omega RC whole square. This would become C, a plus b into a minus b would be a minus a square minus b square. So this would become minus, so we have here j square into omega square LC minus 1 whole square, right? So let me write it further. Z will be equals to, now equating the real and the imaginary portion. So right, see where here we can replace j square by minus 1. So these two part are real part, right? So I can write here omega square into RLC, and this would become minus 1. So this will be minus R times omega square LC minus 1, and further we can write the imaginary part, so taking j common, so we have here omega L minus omega L into omega square LC minus 1, and we have here minus r square omega c, right? So I can write here further whole divided by, we have omega r c whole square, and this would become c plus 1. Okay, c minus j square with this plus 1, so plus omega square lc minus 1 whole square. So now I can write it further as z equals to, so dividing the, so separating the real and imaginary parts, so we have lc minus 1 into r, also we have divided by the denominator part, that is omega rc whole square plus omega square lc minus 1 whole square, plus we have the imaginary component, so let me multiply it inside, we will get omega l minus, we have omega cube into l square c, right? Further we have minus r square into omega c, okay, divided by the denominator part, that is omega r c whole square plus omega square lc minus 1 whole square. So now to find the frequency or to find the value of omega, we have to put that we have to put the imaginary part, this imaginary part we have to equate it to 0, right? We have to equate it with 0. So on equating the imaginary part with 0, we will be left with omega L. See, the numerator part only will be 0 to make it equal to 0. So we have omega L minus omega cube L square C minus R square omega C will be equal to 0. So taking omega common, so we will get here L minus omega square L square C minus R square C will be equal to 0. So here I can write omega square L square C will be equal to R square C minus, oh, this would be minus R square C plus L. Okay, so we will get here omega square would be equal to, so L divided by L square C minus R square C divided by L square C. Okay, so here I can write further, this L will cancel out and this C will cancel out. So omega will come out to be 1 over LC, omega square will come out to be 1 over LC minus R square over L square. So from here I can write the value of omega would be equal to under the root of 1 over LC minus R square by L square. Now we have to find the frequency, and we know that frequency is given as omega over 2 pi. Okay, so we have frequency relation as this. So putting the value, we will get frequency equals to 1 over 2 pi times under the root of 1 over LC minus R square by L square. So this is the required relation that we needed to prove. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.